Afternoon, everyone. My name is Kafero Gabjo, and I go to Colbell Senior Secondary School, and I'm in Form 202. So today I've come here and you see the different apparatus in front of us, including we have this is a separating panel. As you see, it's a separating panel here, right here. So our next apparatus that we have in front of us is a beaker. Yeah, we have a beaker totaling to 250 milliliters. Yeah, so as well it's a second beaker. Then the fourth one, what we have a bottle of cooking oil. As you see, it's just little cooking oil. Yeah, in a big bottle. So our fifth apparatus in front of us is a retort stand. Yeah, I think most of you or all of you know what a retort stand is. Yeah, this is the apparatus used in the laboratory for holding equipment. Yeah, so it will be helping us in this practical that I'm going to do for you today. So it will play a big role this retort stand. So as I begin today, as I told you, today we are going to I'm going to work for you a practical of just separating mixtures. Yeah, that's a senior one topic of separating mixtures. So I'm going to just do it practically, as you see, with the help of my equipment that are just here in front of us, with just a book here, which will guide me, yeah, for the procedure. So I'm going for the mixtures and I'm going for a liquid. There are types of mixtures. First, we have solid liquid mixtures and we have liquid mixtures. So for today, I will be working out for you liquid mixtures. So meaning that a liquid mixture is a mixture whereby two different types of liquids are involved and they can be separated. So that's a liquid mixture. So it will be under miscible liquids. Yeah. So as we'll be looking at this, so we have what we call a miscible liquids and immiscible liquids. So this falls under miscible liquids of liquid mixture. So they are saying that miscible liquids are liquids which even mixed which are even mixed in whatever proportions, yeah. So which meaning that these miscible liquids can be mixed under different proportions. Yeah? I can get a different liquid from a different liquid. I mix them and we can separate them differently. So that's what they're meaning. They can be separated in whatever proportion. So they are saying from distinct layers. Yeah. So as we are going to do our experiment, you will be seeing the different layers involved when you are doing this. So that's what they are saying here in our textbooks. And they are saying such liquids from distinct layers because they have different densities. Yeah, so that will be very great for us because as I told you, this will be a liquid mixture which falls under miscible liquids. So we shall look at what we call the layers involved when we are separating these mixtures. You will see that for example, if I get this cooking oil here that you are provided and I drop it into the separating funnel and I add water, so you will see they will separate. Now when they are separating, there will be some small layers formed on our separating funnel here. You will see the layers are formed here, so which will show you that these are miscible liquids. So we have examples of miscible liquids which include water and cooking oil. We have water and paraffin or kerosene. We also have water and carbon tetrachloride. Yeah, of course we also have water and chloroform. Yeah, chloroform and water and benzene. So for all that, those are examples of miscible liquids. But for this case, we are going to look at the first example that we are given, which is water and cooking oil. As you see here, I have cooking oil, and you also have here my light and tap, so which will provide us with water, as you see. So which means we are going to carry out a liquid mixture. So the first procedure of separating the mixture of paraffin from water. What we need to do first is saying that The mixture of paraffin and water transferred into the separating funnel and left to stand for a short time. So meaning that I'll first get this separating funnel and I drop it on our rated stand. As you see here, our rated stand. So I will just maximize it. After that, I have to make sure that this thing, when I just maximize it by turning around, like it widens and it narrows at a time. So I have to make it widen, and I make sure when it widens here, these separating funnel of ours can be able to fit in here. Now you can see here, it's not fitting, so I can keep on. I can widen it, and not until it can be able to pass through. So you can see now it's able to pass through. Now I need to minimize it a little bit so that it can be caught and it can be in a firm position. Yeah, as you see there, it's now in a firm position, but there is a problem that this small metallic ring is a bit able tilted. So we need to make it also firm so that it can be straight and our experiment should be accurate. So as you see here, I've just dropped it on, this separating funnel. Yeah. So that's it. So what I need next to do is to get this beaker of mine. Yeah, this beaker of mine. So when I get this beaker of mine, first I can use either to first use this oil, cooking oil. I first pour it into our separating funnel, or I can first get water and I pour it. But for our instance, I'll first pour the water in the cooking oil. Sorry, I'll first pour this water into the separating funnel such that you can see how these layers will be formed. So let's do it. I'll get my beaker here. I go to this tap provided. I open it and the water will be able to come, as you see. So let it reach 100. Oh, sorry. So it's now 200 milliliters, but I will just pour it a quarter of it and make sure that it's just a half of this separating funnel. So I just get this water and pour. Sometimes you can use a funnel, but now you can see here the water is just pouring out. Reason being, this separating funnel is contained or is provided with a tap down here. So when you pour some liquid, when the tap is not closed, the liquid will just pass through, as you see. But it's provided, this separating funnel is provided with a tap here, this turning point. So it's the one that helps to turn this separating funnel so that you can close and opens the hole provided down for water to let through. So I've just closed it. Now I can pour through my liquid. Let's see. Now when I pour the liquid, this water of mine won't now pass through like the other time. So I have to pour it until it can be able to be seen. Yeah. There, I think now you can see clearly. So after me adding this water, reaching half of the separating funnel, I just need to get this cooking oil of ours because our experiment or our practical is talking about separating water from the cooking oil. So let's do it and we see the outcome. So I'm going to just get this small cooking oil. I add it to this water provided so that I can see the result that's going to come. So I get this cooking oil, I pour it gently. Yeah. So as you can see here, there are two layers formed. As our definition was saying or explaining to us, that these municipal liquids sometimes, or when we are carrying out the experiment, there are some layers that are formed. So as you can see here, there are two liquids, but they are added into the separating funnel. So we just now what we need to do is to separate these liquids from water from cooking oil. So that's what we are going to do. But before I do that, this water, we need one beaker filled with water, then one beaker filled with oil. That's how we are going to separate it. So I have to first pour this water out so that I can get an empty beaker. So that we are going to do. So for now, as you have seen, there are layers formed, but they are like 2 layers. The first layer is for cooking oil, the beginning point of cooking oil, and this second layer here is just a layer of water, like it's a separating layer from cooking oil. Is a separating layer of water from cooking oil. As you can see, they are separated already, but we need to make sure that they are permanently separated, because still water is still in this separating funnel, so we need to separate it. Yeah, so how do I separate it? Now, I remember I told you that this separating funnels contains just this little turning around this. It's like a tap, yeah, a turning point. So I just need to open it, as I showed you that when I pour the water, when it's open, the water will just pass through. But after closing it, when I pour the water or any other liquid, the liquid won't pass through. It will just be captured and remain in this tank of the separating funnel. So as you see there, I will be separating by opening the tap or this turning point of this separating funnel. So what I need to do, I make sure that I have one beaker in presence that will help me to put directly like below this spout of the spout of the separating funnel. So I make sure that it's in position such that our liquid is not poured out or mislead. So as you see, I have to first measure, then it's in position for this water to get dropped into this beaker. So let's do it. I'm going to turn the turning point, and then this liquid will be out. Yeah, so as you see what I'm doing, I will tilt it a little, not until the small hole formed on this tap is equal to the hole of the separating funnel. So when I separate it, that's how it will be. As the water is passing through, you can see this cooking oil is still there, but it's moving. So meaning that this water is the one moving out. So we have to time it not until it reaches near the spout or the outlet, such that we can close it. Yeah, so that's it. Now we have closed it. Now this is our plain water that we poured at first in order to make sure that we can see the layers and how this thing can be separated. So this is our water that from separating this cooking oil, meaning that I first poured the water and then I poured the cooking oil. But some people will be like that, but Gabriel, you have poured this water first, then you pour cooking oil first, which is very different, which meaning that though I begin with the oil and then I pour water, will it separate itself, or you first need to separate it by turning this filtering funnel. So what I need to do, that's not it. When I'm separating the liquids, any liquid that you first drop in the separating funnel, then you drop another liquid, will still give you the same result. Now some people are wondering that I first pour the water, then I pour the cooking oil. Automatically the cooking oil will come up. So let's repeat the same procedure, but this time cooking oil will be at the bottom, then I will need to get this water of mine, I pour, we'll see what will happen. So let's do it. So I'm going to get this water then that I'm from separating, then I add it to the cooking oil. We'll see, or it will give us the same result, or it will be now this time a different result. So I get this water that we are from separating. Now as you see, when I pour it out, because this time the cooking oil was at the bottom of the separating funnel, but as you can see our result that's giving us. Yeah, so last time the water was being first poured in our filtering funnel, and we poured still the cooking oil at the bottom. But we have made sure that this time the cooking oil is at the bottom, then I pour the water above. I pour the water above the cooking oil. But you can see the result that it's giving us. It's still the same result as first as it was. So meaning, what's this? Meaning that these two liquids, cooking oil and water, they are different, or they have different densities. So meaning that this water is denser than the cooking oil, and meaning that this cooking oil is less dense than water. When we flash back to physics, there are some properties that of floating and some properties of floating and sinking objects. But for this time, you can see this cooking oil is floating, meaning that this cooking oil is less dense than water, because we first pour this cooking oil. Okay, we've separated this cooking oil from the water, and we separated this water from the cooking oil, meaning that after that, when we separated, the cooking oil remained alone in this filtering funnel. So we got this water, and we made sure that the cooking oil is at the bottom of the filtering funnel. When then we pour this water back. When we pour this water back, we saw, or we have just seen, that this cooking oil which was at the bottom just came back and it floated on the top of the water. Yet instead, this water was just poured in, for the second time when the cooking oil is at the bottom, meaning that this cooking oil is less dense than the water, and the water is denser than the cooking oil. So still, I will separate this, and we get our uniform result that will give us to prove that this cooking oil is less dense than water, and to prove that this water is denser than this cooking oil. So meaning that these two liquids, they can be separated. Yeah, these two liquids, they can be separated easily. So you can try it at home also. Just get a cup, get some small water and cooking oil. You try it yourself. You see they will separate, but they can separate as you see. I've done it. So I will remove this water first for the cooking oil to remain. Yeah, but also don't forget to look at the layers that we talked about. There are two layers that are formed. There's the first layer at the top of our first liquid, which is cooking oil, and there's our second layer which separates water from the cooking oil. So we shall still remove this surface water so that we can get our uniform results, as you see. So I'm going to remove this water by tilting this turning point of the filtering funnel, so that we can get our final result, and we mark it down. When you make sure that you're turning this turning point of the filtering funnel, turn it slowly and gently. Make sure that you don't just turn it anyhow. So as you see, I'm just removing this water which we have just added before the cooking oil. So, and you have to make sure that this thing has to be timed so that this liquid, this cooking oil, cannot still join with this water. Now you can see we have just received our water and it's just plain, no cooking oil here. Yet we have just mixed these liquids together, both two liquids, but we have just seen we have got a different result, which meaning that this water is now plain water and this is a plain cooking oil. So for that incident, I'm going to add our cooking oil back to our where it was got from this bottle. Yeah, to show you, but you have seen that this water, we have already proven that this cooking oil is less dense than water, and this water is denser than cooking oil. Because we first pour this cooking oil. At first, we use this water, we poured, then you added cooking oil. And some people will be like, no, you have first poured water, then cooking oil automatically. The last thing will be on top. No, I've shown you what has been done as well for those people complaining. I've explained to you, and we have repeated this experiment for the second time, and I first filtered this water, still now letting this cooking oil stay at the bottom of our filtering funnel. After separating, then I got this plain water. Yet this cooking oil is at the bottom. After adding the water, we saw automatically that this cooking oil that was at the bottom will now still come up slowly. Yeah, and that is already proven that this cooking oil is less dense than water. So I will need to remove our cooking oil. It's now plain cooking oil. It's not mixed with water, because from just separating water from cooking oil, as you see. So I will just turn it to drop this cooking oil back to the bottle that it was got. So when you are doing this, you have to be careful and gentle. So to make sure that anything that happens. So as you see, I'm now separating. I'm now removing my cooking oil, plain cooking oil. There is no water contained in my cooking oil, as I shown you with the explanation that we have just done here. So our cooking oil is just being hot and it's plain, yet we are mixing them, and we separated them probably. So you can still use this cooking oil for cooking, cook yogurt, fry, and all the other stuff. So as you can see, the cooking oil is now over from our filtering panel. Yeah, so that's how our experiment has been. Thank you.